I just wanted to say good morning to everybody, or good afternoon as the case may be, and it's my pleasure to welcome you to today's webinar titled Secret Weapon for Analyzing Wireless Communication. And hey, thank you very much for joining. Keysight's really excited about the acquisition earlier this year of Sanjole and their unique WaveJudge solution, which will be at the center of this webinar. As we were getting started, I heard somebody commenting on that, so sounds like some of you may be familiar with it. My name is Brad Collingwood, and I'm a wireless sales specialist. I support account managers throughout Canada, and I work with product specialists like Kevin Dobis, who's leading today's discussion, to help our customers find the right solutions for whatever their wireless testing needs may be. So just before we begin, let's cover a couple of housekeeping items. You may have noticed we've intentionally limited the number of participants in this seminar, partly to facilitate questions and discussion. We strongly encourage you to jump in at any time in the presentation with questions. Don't hesitate to take yourself off of mute. There's the mute button, the microphone button. As usual, you can just take yourself off of mute and ask questions during the session. We actually prefer that. But if you'd rather, there is a chat bubble at the top right corner of the screen where you can enter your questions there. Those will go out to everybody unless you select a specific individual. And we'll try to answer all these questions during the webinar, but if a more complete answer is needed, or if we run out of time, we'll answer all the questions via email, and we'll make sure to capture all the questions. And as Leslie just mentioned, at the conclusion of the webinar, we'll send out not only the recording, but also the slide deck, so you'll be able to reference that with your colleagues or on your own. And we will have a quick poll at the conclusion of the presentation. And there you can indicate if you'd like to schedule a demo or maybe just receive additional information. Would love to follow up with you on those requests. Or there will be an evaluation that pops up in your browser at the conclusion of the webinar. And in there you can include any comments you want, and we can follow up on those. So again, we really appreciate your attendance today. I will hand the session over to Kevin, but let me first just provide a brief background so you know a little bit about Kevin. Kevin joined Sanjole, which again is now part of Keysight, in July of 2009. He's actually responsible for all WaveJudge activity in the Americas and EMEA, so he's got a big area of responsibility. Prior to joining Sanjole, that was just about 12 years ago, Kevin spent 13 years with Spirent Communications in various sales and executive management roles, including vice president of sales. And before that, Kevin spent 9 years in the test equipment market in various sales and sales management positions, including work with TTC, which is now Viavi. I heard someone mention them earlier, Heckman Labs, and Laser Precision, which is now part of Anritsu. So you can see he's very experienced. And although Kevin, he's been heavily involved in sales, he holds a bachelor's degree in electrical engineering from Pennsylvania State University. So we're in good hands. Thank you again for joining. And again, please jump in at any time with questions as Kevin is going through his presentation. We'd like to have a discussion with everybody. So with that, Kevin, take it away.
Great. Thank you, Brad. Thank you. I think with an introduction like that, all it means is that I'm old. It means I've been around for maybe a little too long. But anyways, as Brad mentioned, some of you probably have heard already if you've worked with the Sanjole in the past. Sanjole is a very mature company, probably been in business for more than 20 years. And earlier this year, we were acquired by Keysight, and mainly, we were gonna partner up with Keysight for the 5G, a lot of the 5G activity we've done. So, definitely, great to be a part of the Keysight team. And what I'm going to do today is give you all an introduction to the WaveJudge. Some of you may have interacted with it. Some of you may not have. So I'm going to give an introduction to the WaveJudge 5000. I'll give you an overview using some PowerPoint to give you some background. Where does it fit in? How, what kind of things do we do? But I will also switch over and show you a demo using the real WaveJudge GUI. What you see now is the real live WaveJudge GUI. So I will be bouncing back and forth between the PowerPoint and the demo, the live GUI. And then at the end, we're going to stop for some Q&A. But as Brad mentioned, I prefer that you interrupt me right in the middle of my speech and do questions. I think it's much more effective. I prefer a dialogue as opposed to a monologue. So please, any questions you have, just go off of mute, stop me, and let's get the questions out there, straight off the bat. So, what is the WaveJudge? The easiest way to describe the WaveJudge is that it is an RF sniffer. So the WaveJudge will capture an RF signal, and the analysis it gives is protocol analyzer type analysis. Okay, so that's the high level. What does a WaveJudge do? The WaveJudge does that with a system of two parts. Part number one is the chassis. So there's a WaveJudge hardware device, which actually does the capture. The WaveJudge chassis is used for nothing more than capturing the RF signal, and it passes that information onto a Windows PC, and the WaveJudge software analyzer runs on the Windows PC. Okay, and we do that for both 4G and 5G networks. There are some other things we do that are not very, let's say, common today. Wi-Fi, WiMAX. We've been doing WiMAX for probably 20 years, and some other stuff as well. I will not discuss that today. The focus of today's talk will be mainly on 5G, touching on 4G, and we'll limit it to that. If you'd like more information about some of those other technologies, ping us or send us an email. We can help you with that. So WaveJudge has a hardware chassis and software, but it's very versatile, very flexible, and we have multiple form factors. Okay, versatile, flexible means we can do 4G by itself. You don't need the 5G side. Or we can do 5G by itself. You don't need the 4G side. And you can actually use the software only. It's not even necessary to use the WaveJudge hardware. Okay? If you are using some other hardware device to capture an RF signal, or you may have some other hardware device that that provides an IQ file. We see this a lot in the Oran space. If you're doing any kind of capture of an ODU or an OCU or some other things. Or you may be using other Keysight hardware. Maybe you have a Keysight UXM or really almost any other Keysight device. You can use that as the capture device and export the IQ file. And what that means is you don't need to use a WaveJudge hardware. We use a WaveJudge software analyzer only. Okay, so very versatile, very flexible. Capture RF or take an IQ file on 4G, 5G circuits, and we give you some analysis. And I'll show you as we go through this, what kind of analysis we can do that on. Looking at an operator space, this talks a little bit about, what do the mobile operators might be interested in, like Bell, Telus, Videotron. We do a lot of work in those labs. So this is kind of a use case. What do we do when we capture that RF signal? We do a lot of tests on, G node B and UE attach, and that's for interoperability. So for example, you might have a G node B and multiple UEs. You might have an Apple, a Samsung, all these different UEs, and we can do a test, an end-to-end test that helps you, determine what's happening on all those different interoperabilities. Throughput, we can look at throughput of that thing. And really one of the big things is we stop the finger pointing. What we see quite a bit is because we're capturing the RF signal between the UE and the base station, we stop the finger pointing, right? Whenever there's a fault or an error, we can determine who is at fault. Is the UE doing something wrong, or is the G node B doing something wrong, right? The G node B will send a message to the UE. It expects a message and reply, and we see all those messages and can really help troubleshoot that stuff. And then as well on the scheduler, we do a lot of work with the operators on testing the G node B schedulers and LTE schedulers, et cetera, et cetera. Okay, where do we do that? Where do we fit into the network? The WaveJudge sits in between the base station, and on the left side, I show a whole number of different types of base stations. Okay, it can be a real E node B or G node B. So if you have a lab environment with a real, Nokia, Ericsson, Huawei base station, the WaveJudge will capture all the RF signals coming on the downlink from those real base stations. We do the same thing for small cells. So if you have a small cell network, the WaveJudge works in that environment as well. Oran, no problem. And it can even be a simulated base station. So if you're using the Keysight UXM to simulate the E node B, G node B, no problem once again. If the downlink RF signal coming out of that device will be captured by the WaveJudge. So very flexible, very versatile. Any type of base station, real or simulated, 4G or 5G, we capture all the data. Same thing happens on the device side, okay? On the device side, it can be a single UE, it could be a real UE, it a commercial UE off the shelf connecting to the base station, and we're going to show you all the information, all the messages that UE is sending in the uplink. It can be multiple UEs, okay? The WaveJudge is a multi-UE device, okay? So if you have hundreds of UEs in a sector, the WaveJudge will capture and show you data for all of those UEs, including a simulated UE. If any of you are in a lab environment, you may be using the Keysight UE simulator. Brad can give you more information on that if you're interested. But again, doesn't matter if it's a real device, a simulated device. Whenever that sends an uplink RF signal, the WaveJudge captures it and gives a lot of analysis for that. And I'll talk about that very shortly, okay? The WaveJudge can do this in two environments, in a lab cabled environment, and you can see that here, right? If you're in a lab, the base station or the base station simulator is connected to the UE or UE simulator with a cable, and we will throw some splitters on there, and that's how the WaveJudge captures the RF signal. So this slide shows a Keysight UXM base station simulator. So we're simulating a 5G downlink, and the WaveJudge peels off a little part of that RF signal to see all of the downlink messaging. The same thing happens in the uplink. You have a device here, whether it's real or simulated, and it sends an uplink message, and the WaveJudge will peel off a small part of that RF signal to show all of the uplink messages. So this is a depiction of what we do in a lab environment, okay? We also operate over the air in the field, and that's a slightly different configuration. In that configuration, it's almost easier for the WaveJudge to handle because all we do is we connect antennas to the front of the WaveJudge. So here's a downlink antenna, here's an uplink antenna, and if you put this in a lab anechoic chamber or out in the field, we're going to capture all the RF signals that the antenna can grab, okay? And you don't need cooperation from the operator. So you can do a test on the Bell Telus Videotron network without coordinating a test with the operator. So you can take the WaveJudge out in a van, turn it on, and immediately start capturing 4G or 5G captures. And we're going to show you some analysis of, what are all the devices on that network? We can see, everything that's happening in the downlink, the uplink, all the users, et cetera, et cetera.
Hey, Kevin.
Yes.
Yeah, I just got a question through chat here from someone asking if the WaveJudge, and you're probably maybe going to cover this, but if the WaveJudge can decode CV to X protocols.
Yeah, so that's a very good question. The answer is yes. So we do capture CV2X protocols, and the reason that is because we actually support all of the 3GPP spec. Everything in the 3GPP spec we support. So CV2X on the 4G side is a release 14 protocol, and yes, we support all that. Okay, you're also going to find some CV2X. I believe it might be in release 16. It might be release 15, but we will capture the 4G CV2X protocols, and we will capture the 5G CV2X protocols and give you the full protocol decoding as displayed on this window. Very good question. Okay, so again, versatile. WaveJudge captures 4G, 5G. It does it in a cabled environment. It does it in a lab or a field environment. Multiple cells simultaneously, multiple UEs. There's really nothing that we miss. There's really nothing that we don't capture or support. That's the headline. So let's discuss now about, what do we do with all this data? We're going to be able to capture all this RF information. What do we do with it? And there's actually two very distinct types of analysis that we give, and they're really kind of different. It's almost like the WaveJudge is two different analysis tools in one, okay? Analysis type number one is physical layer. It's the phi layer, the RF. It shows you data about that RF signal that we've captured. And you see that over here on the right side of the WaveJudge GUI, okay? What you're gonna see is a lot of data about the RF, constellation diagrams, time domain power. We show you the resource block map. So you can see where all of the sync signals are, where's the PDS-CH, where's the downlink transmission, where's the uplink, and you can see in the time domain, in the frequency domain, where all that stuff is, spectral power. But we are not limited to these four windows. If you right click, you'll notice that we give you a lot of physical layer RF parameters and analysis. One of the big, very important ones for 5G is beamforming. Today with the installation and kind of a brand new 5G installation, you may want to, move the beam around and see what the WaveJudge says is happening on the, the various 5G beamforming tests. So the point is, on the right-hand side of this window, we have a lot of varying and different, phi layer, physical layer analysis. Okay. The second type of analysis is a protocol analyzer. Okay, and we show you the layers 1, 2, 3, 4 protocol analysis, and we do that for both the user plane and the control plane. So we do both. On this window, you'll see that here in the middle. So here you can see all of the control messages of a UE attach, and you can see both uplink and downlink messages. So I can tell you that a particular UE sent an uplink message, and it's trying to join the network, right? It sent a RATCH. And then the base station transmitted a downlink message, and it sent the message too, right? The random access response. And the WaveJudge has a lot of smarts and expertise built into it, and it'll tell you whether these messages are correct and accurate and okay, or if they are errored. Errored means a lot of things. The user does not need to be an expert on 4G, 5G protocols. So you don't need to know much at all about the 5G protocols, because what we do is we look at the protocol itself. So if you double click on the message, we can see all the protocol and we know whether it's following the 3GPP spec or not. So category number 1 is we do a protocol check. However, the physical layer window over here is also tied together with that protocol check. So these two windows are correlated. They kind of work together. And the other thing we do is we determine whether that message, the random access response, is in the correct resource block, resource element location, which means we check that it's in the correct time slot. We check that it's in the correct subcarrier, the frequency, and we know exactly where all this stuff should be. And we also check that as well. So it's not just a protocol error checker. We also check layer 1 and all the other protocol layers as well. And if there's a problem, you'll see an error here. Okay. So, moving down the protocol, we see that the normal protocol exchange for all of the control messages are here, and they're all okay, right? And it ends with a complete, right? It ends with an complete, so the UEs join the network. And then we see all these NAS messages. We see all the NAS messages, which is now starting to turn on ciphering, and then the reconfiguration, et cetera, et cetera. So point is that we're showing you all of these protocols, and right now I'm only showing you the layer 3 stuff. However, the user has full control over the other protocol layers. So right now, I do not have layer 1 transport block turned on. If I expose the transport block physical channels, you'll see now, you can see all those PDSCH, PUSCH, PDCCH, everything. All of the physical channels are exposed. If you're not interested to see those, we hide them. You want to do a test for DCIs on 5G. This is very important, DCIs, because there are a lot of new DCI formats, all right, in 5G. And today we're seeing a lot of errors on some of these DCI messages. So again, you don't need to be a protocol expert to determine whether some of the new 5G DCI formats are correct. We will tell you there's an error if there's a problem. Okay. And if you're not interested in doing a test on DCIs, we hide it. MIB, SIB, et cetera. So the point is, we're showing you all of these different protocol layers. We're on the control plane and the user plane. So the user data will also be in this window. You're going to see IP packets. So we can do tests on, we can show you SIP and RTP voice packets and pings and UGMP, all the user data in addition to the control. And we tell you whether there's an error or there's no error. We give you information about which user, which device is sending this message, right? We can show you the IMSI, the power measurements. So there's tons of data and information and power and protocols that's available. But the way we present it to you is in a very nice, easy format with error checks, so you don't need to dig in and delve down into some of that stuff unless you see some problems or errors. Okay, so I hope that's a good description of how we do protocol test and how it may be important to tie that into some layer 1 stuff as well. If you're not interested in the layer 1 stuff, maybe we're only doing protocol, so we hide it, right? Let's just focus on the protocol. We don't really care about the RF stuff. All the RF may be working today, right? Once 5G becomes a little mature, Layer 1 is rock solid. Okay, let's just look at the upper layer stuff. So again, very flexible on what the WaveJudge will show you, what you want to see, what we expose to you, etc. Okay. All right. Oran. Yes, we support Oran. And here you can see a 5G Oran network. And the network, or the base station, has been disaggregated. So we show you here that there's an ORU, and the ODU, OCU are back here on the front hall and mid hall. And from a WaveJudge perspective, right, here's the WaveJudge, nothing changes. So if you have an Oran network, or you want to do some testing of an ORU in the lab, or an ODU or an OCU, we can do all of that, because we still capture the RF signal between the ORU and the UE, or a simulated UE, right? Here's the Keysight UE simulator. So whether it's a UE simulator or a real UE, WaveJudge captures it. We give you all the normal analysis. If you want to look at the analysis, the same analysis, all the same analysis is available on the ODU and OCU. So maybe you're doing some development back here. What we do here is we don't capture an RF signal. What we do is we take an IQ output. So the ODU or the OCU outputs an IQ file, and we simply input that into the WaveJudge software package. Again, versatile. You don't need to use the WaveJudge hardware. You can use the analysis package with IQ files coming from anywhere. Okay. Here's what we support. As I mentioned earlier, from Brad's question, we support everything, right? We support everything in the 3GPP spec. So today, we have been supporting release 16 for more than a year now. Whenever the release 16 spec was, finalized, we usually have the software available before the spec is released. As an example, release 17. Today, we already have release 17 software sitting on the shelf, and we're ready to release it as soon as the 3GPP folks ratify it and finalize it. Okay. So, release 16, we've been in this space quite a long time. Again, if you look at the 4G side, we support CV2X, narrowband IoT, if anybody's doing NB-IoT protocols, all the 4G stuff. And then again on 5G, there is nothing we miss in the 3GPP spec 5G. So we support standalone, non-standalone, all of the release 16 stuff, ultra reliable, low latency, wake up signal, everything. We already have release 17 sitting on the shelf ready. As soon as it's finalized, we will release it. TDD, FDD, no problem. All of the channel bandwidths up to 800 megahertz. This is where the current 3GPP spec stands. So yes, we support 800 megahertz, and we do that with, for example, 8 times 100. So if you're testing a network or a device that's 8 carriers, 100 megahertz bandwidth each, no problem. One WaveJudge input can handle that. All of the higher order MIMO schemes, 4x4, 8x8, all of the frequency bands, FR1 and FR2. Okay, all the numerology, et cetera. So essentially what I'm saying here is in the 4G, 5G space, we support everything in the 3GPP world, no problem. Okay, good. Hope that's obvious. A couple use cases, what do we do with all this data, or, why would you be interested in a WaveJudge? There are a number of use cases that we have in government applications. We do some stuff. I've done some work in the past with the RCMP and some hydropower companies in Canada. And they're looking at some things that are not typically a 5G network like you would consider from Bell or Telus as an example. They have some maybe 5G private networks, or they may be installing a 5G private network. And we help them with that as well. We can do that by doing some record and playback, and as well as security. We do some work with the government agencies on all of these fields, and I'll give you more detail here in the next few slides. So on record and playback, there are a number of things we can do there. So you can go out to the field and do some recordings only, and we don't do the analysis during the recording. So you can send someone out to the field and do a number of captures and recordings for coverage tests, right? We can do signal reconnaissance. We do a lot of work with some of the 3-letter agencies and the Army and various military DoD type for a lot of this type of work. So they'll do some collections at a particular location. They may move location and see what's happening. As an example, we did some work in the U.S. where the DoD did some collections near the Capitol building, right? We remember what happened on January 6th at the U.S. Capitol building. So what they've started to do is let's go do a capture around the Capitol building, and they're going to count how many users and what they do is they actually count DCIs. So they're counting the number of DCIs on that network. They're going to count users, and then they store these recordings, and the next day or the next week they return. And if they see a huge increase in the users in this particular site, they may even do this every hour. Maybe they do a count every hour. And if they see a spike, the users went from, maybe there were 300 users here and all of a sudden there's 1,000, there's a red alert that something's maybe happening in that area. There's also work happening today with the government agencies in 5G labs. A lot of the government agencies are trying to study 5G. They may be doing 5G hardware development. They may be looking at 5G base stations and regression tests. They may be looking at 5G versus 4G side-by-side stuff. So, you'll see that there's a lot of applications the WaveJudge plays into in what I kind of call non-standard networks, right? They may be private networks, they may be government, it may be security, et cetera. Okay. Also, there's a big play right now in the security of 5G. I don't know if any of you have been looking at some of the press or you can Google some of this stuff, but there's a very big concern that 5G is not a secure network. And we did some work with AT&T in New Jersey where, and again, you can Google this. If you Google the AT&T Chief Security Office, AT&T CSO, what they did was they proved that there's a 5G security threat with rogue devices. And what they did was they took a phone, they took a device, and they did a ratch flood. What it looks like if you remember the old Ethernet days where there was a denial of service attack, right? There was some rogue user would do a DOS attack, and you would just flood the network with DOS messages. There is an equivalent in the 5G world. And what happens is AT&T did a test where they took a rogue device and they sent a ratch message. Remember, the ratch message is how you join the network. Okay, the ratch message is sent, and it's sent in the clear. There's no security, there's no ciphering. And when the base station receives a ratch message, it tries to process that. It tries to find out, who are you? What is the IMSI? It sends back some of these other messages, right? And it doesn't yet know who the device is. So there's a lot of processing wasted on the base station by sending some of these messages if you are a rogue device. The base station realizes that you are not supposed to be on the network, and it does a rejection. So it will reject you. However, the device sends another ratch and another ratch and another ratch. And we have done some work again with AT&T where we did some captures of this research, and we saw the ratch message was repeated hundreds of times. Our window just showed ratch, hundreds of ratches, and the network crashed. Okay, so that just gives you an idea, how do we do rogue base stations? We can go out to the field, do a capture, and we can see whether the G node B or the E node B should be, is it a part of the TELUS network or not? Is it a part of Videotron? Rogue devices, location, we can, because we see all of the devices and we find DCIs and we have all the information, all the protocols, we can even do, location of some of the handsets. And that's a big application in the military. And then the last one I'll talk about is ciphering. We get asked quite a bit about, well, what if the message is ciphered? How do you decode that? And the answer is, yes, we do decode ciphered messages. And we do that with a special hardware device that we've developed called the CipherJudge. And the CipherJudge is very simply a key sniffer. Okay, so what we do is we intercept the cipher key. We intercept the key exchange. The way we do that is we have this CipherJudge it's a very small device. You can tell that it's smaller than an iPhone, right? It's pretty small. And the method is you must remove the SIM card from the device. So we take the SIM card out of here and we insert the SIM card into the CipherJudge hardware box. Okay. And then there's a cable that connects back to the SIM slot or the SIM tray, the SIM slot. Okay. So what happens is when the phone communicates to the SIM card, the communication passes through the CipherJudge box, and we find all those cipher keys. So when the phone is turned on for the first time or it comes out of airplane mode, it communicates to the network, it does a key exchange, it's communicating to the SIM card, and there's an agreement on what the cipher keys are, and we see all that stuff. So the CipherJudge takes the key, it sends the key onto the WaveJudge software, and now these are ciphered messages. A lot of these NAS messages and all of the RRC messages after the NAS are ciphered. But we can decode those even though they were ciphered using that CipherJudge. So it's a pretty cool application, and it can be used in military applications. Again, you can do it in, there are a lot of government applications for that, but there are also commercial applications for this CipherJudge. For example, smart meters. If Hydro-Quebec or one of those, one of the providers in Canada would like to do meter reading, if they want to read the meters over the 4G or 5G network, the WaveJudge can capture all that data, and using the CipherJudge, we can decode all those messages. We actually did this with an operator. I won't name who it is, because every night at midnight, their network was crashing and they didn't know why. So this photograph came from a real operator lab, and we did a test where we connected to these smart meters, and I think we did a capture that was very short, a few seconds, maybe 5 seconds long. And what we saw all of the RATCH messages from each meter being sent at the same time. So on a very short capture, we saw we said, again, we saw RATCH for all of the smart meters, and it was crashing the G node B or the E node B. Okay. So again, some of these applications are not what I would call typical operator type, it's not a typical 4G, 5G network. Some of it's in factories, some of it's the smart meter stuff, et cetera, et cetera. Okay. We're also going to give you a copy of all these slides. So I have a couple of reference slides at the end, right? At the end of the presentation, you can see that the protocol layers we operate on. So we show you all the information for MAC, RLC, PDCB, RSA, and NAS. All these protocol layers are decoded here, and you can see an example of some of those messages, okay? And also a little bit of information about a summary. The summary of the WaveJudge is, here's all the different protocol layers. You can see the screen, and we can record all of those conditions over the air or in a lab passively. Remember, the WaveJudge doesn't require any coordination. The WaveJudge does not capture the RF signal and repeat it. In other words, we don't change the RF signal, right? The RF signal does not pass through the WaveJudge. So a lot of this stuff is done all passively, and we're going to give you total insight into everything that's happening on the 4G or 5G network completely. And whether that's a private network, the public operator network, government's work, et cetera, et cetera. Good, I hope all that's clear. Okay, let me show you a quick demo just to give you a feel for some other things that are very, very important about looking at the WaveJudge analysis. I've already alluded to a little bit that this protocol window is connected to the physical layer, the RF window on the right-hand side. And I showed you that with this 2D power, with the resource block map. However, that applies to all of the diagrams. So for instance, if you wanted to look at the time domain power measurement, this graph shows you the WaveJudge captured power over time. So what we can see is that this is an uplink. So this is an uplink capture. And we can see that the UE is not transmitting, and then there's a bump of power. The UE is not transmitting, and there's a bump of power. So just, nice visual. I can show you that it appears like the UE is trying to join the network. Okay, and I can see that because the way the protocol works is the UE sends a RATCH, a burst of power, and it waits for the base station to, join the network. If it's not successful, it sends another RATCH. However, the second RATCH should be higher power. Maybe it didn't join the network because the power was too low. So what I expect to see is a ramp. I expect to see the next one to be higher, the next one to be higher. So just visually, I can see that there's probably a problem here with the UE joining the network. However, remember how these two windows are connected together, though. I can even show you what that RATCH, looks like. If I click here, if I click on any one of these messages, I can find it very easily. For instance, if I want to find this, the RSC message or any one of these, I can click it, and using the zoom tools, I can zoom on that particular location and see different power profiles. So for example, if I click on this RATCH, I know the RATCH is located here on the WaveJudge capture, okay? So I can zoom in to a very, very detailed level on that RATCH, and I can see very clearly that the UE was transmitting at a power level here, and then this bump of power is the RATCH. But what's interesting is, if I zoom in only on the rising edge, right? So here is where the WaveJudge tells me the RATCH should start. So the device is supposed to send an uplink message right at this location. But the uplink, the device didn't actually send until it was way out here. Okay, I hope that makes sense. We're showing you that by clicking on the protocol window, it places a marker on where that message should be in the power display, and where the power actually occurs is too late. So you can do really nice troubleshooting. And the reason I bring this up, because on 5G networks, a lot of the 5G networks are now TDD, right? Back in the FDD days, some of this didn't matter. The downlink and the uplink timing, right? When did the downlink send? When did the uplink send? They were independent because FDD, the downlink and the uplink are on 2 different frequencies. 5G is a whole new animal. 5G is more complex. In the 5G world, this is much more important because there's a lot of TDD in the 5G space. And TDD is different because the downlink and the uplink share the same frequency. And whenever the uplink is transmitting, the downlink must stop, and vice versa. So it's very important to see that when the device is transmitting, where is the device transmitting? Because in this location, the downlink the G node B should stop transmitting. Okay, and we can troubleshoot pretty easily, some of those downlink uplink timing problems that we haven't really seen too much of that in the past, but we now see it in the 5G space. Okay, so I hope that's kind of clear. The other thing I'll do is I'm going to turn on some transport blocks, so you can see, here's all my transport blocks. And you'll see how easy it would be also to find a transport block in the 2D power window. So for example, if I wanted to find, by the way, this is a downlink. I'm looking at the downlink resource map. So as an example, if I wanted to find a PDSEH for some reason, maybe we have an error on this PDSEH, or maybe this PDSEH we're interested in that, or the PDCCH for some reason. What's nice that these 2 windows are connected together is that we put a marker on the location of that message. And it works for all messages. So if I go down here and I click on another one, maybe I'll click on this PDSEH, you'll notice this little marker will move. So when I click on this PDSEH, it moved out to this location. And again, if I zoom on this location, you can very clearly see this PDSEH is the pink stuff. You see the pink highlight? And I can zoom all the way down to a low level of this PDSEH and tell you that here's my PDSEH, here's my reference signal. So the WaveJudge paints a really nice picture for you on, where all the resource elements and where should these messages be located in the time and frequency domain. That's really not that interesting unless you overlay that with the actual transmission. Okay, so let me say that again. The picture is a depiction of where all these messages are supposed to be located. And what we can do is we can turn on the power measurement, and we will show you the white block is where the WaveJudge measured the location of the power to be. So we overlay on top of that map the actual transmitted power. Okay, and we can show you that the reference signal is 52 dB, 52.8, and the PDSEH is 12 dB less power. So we can do a lot of, power measurements on individual resource elements, resource blocks, messages. We can show you interference. You notice this here, there should be nothing here. There's no colored block here. Nothing should be transmitted here, but we have some RF power there because it's white. Okay, here's your PDCCH. All right, this isn't that interesting really. I mean, what I'm showing you is exactly what I would expect, right? All of the power, all of the transmissions from the base station are perfectly inside of all the blocks where they're supposed to be located. Okay, let me show you the uplink. If I switch to the uplink, I'm going to show you that. Let me click on an uplink message. I'm going to try to find PUSEH. When I click on it, you'll notice this will move. This PUSEH is easy to find. Okay, and I'm going to show you exactly where it is. It's the yellow one. If I click away, from that PUSEH, you'll notice it's the blue block, right? So you can see that the PUSEH is right here. Perfect, I can tell you find exactly where that is. That's where the device should be transmitting. And if I tell you where the device actually transmitted, you'll see that there's a problem here. And by the way, this was a real capture with a Samsung device. What happened is the operator, we were doing this test with an operator network, and there was a throughput problem. And the operator probably tested for 3 months without understanding why was there a throughput problem. And what we showed, once again, with a very short capture, this capture is only a few seconds long, was that the device was using some of the spectrum, right? We're using some of the spectrum, minus 92 dB, but you'll notice some of the spectrum is not being used. These black holes are not being used. So the device is using some of the spectrum, but it's not using all of the spectrum that the G node B has given it. I hope that's clear. We also know this is a device problem because the reference signal is perfect, right? The reference signal on every location is the same. It's very consistent. You don't even need to hover over this thing to do the measurement because just with your eyeball, you can see the color is all consistent. But the device has a problem, and there's also a lot of interference here. This device really had a lot of problems. Okay, so I think that may be it. I think I'm going to wrap it up here. But what I've tried to show you is the power of the protocol analyzer being used by itself. Some of the things we can show you on the physical layer measurements whenever you use it by itself. But there's a lot more power by using these two windows together. Okay, and when you use them together, you can find what is the effect of some RF errors or some RF problems. What is the effect on the protocol when we have RF problems? What is the effect on the protocol? What is the effect on the throughput when we're not using all the resource blocks or resource? What is the effect on the protocol whenever the uplink or downlink transmission is sent too late or too early? Okay. And again, you don't need to be a protocol expert because we do a protocol check for you. And if there are any errors, we're going to highlight that in red. And it's impossible to miss because, if you just scroll through here, if there is an error, you're going to find it pretty easily. Somewhere along here, there's an error. Okay. So I think that's about it. I hope that gives you a good idea of, what the WaveJudge can do, the power of the WaveJudge. If anybody does have a question, this is a great time to go off mute. I think we're going to first put up a poll. Maybe Leslie or Brad, should I pause here for your poll?
Yeah, this is great. So I'm going to launch a poll for you all and appreciate your answers. Thanks, Kevin. That was a great presentation.
Yeah, stick around after the poll. We still have open Q&A. So
yes.
This is a quick pause so you can indicate if you'd like us to follow up with you, which we would love to do. But please stick around for Q&A.
If you have questions, here's an email address you can send to sjsales@keysight.com. I am actually on this distribution list. So if you have questions after today, you can send it here, or you can ping Brad, or I don't know, you can ping any one of your Keysight, anybody in the Keysight family in Canada will be able to help you. The WaveJudge is fully integrated now into the Keysight world. So, all of your normal Keysight contacts are supporting WaveJudge.
Okay.
And again, as soon as we finish the poll,
I closed the poll out, so if anybody has any other questions or comments, they can also add that to the eval at the end of the training that will come into your web browser.
I see someone off mute.
Yeah, hi Kevin, thanks. This was really interesting presentation. I have a question regarding the deciphering of the messages. You mentioned that you need to essentially connect something to the SIM card socket and read the ciphering key so that you can get those messages. Now, if you are in a network that you don't have access to mobile devices, does that mean that you won't be able to decipher the messages?
Yes, that is correct. In order to decode the messages, we must have the key. So if you're testing like a live operator network and there may be 200 users, you are correct. We will not be able to decode those ciphered messages because we don't have access to the SIM card. However, maybe you have a test SIM. I don't know. So the answer is no. We won't decode the messages from all the users because we don't have access to the SIM card, and that's on purpose, right? That's that's a security risk if we could do that. So you either need the WaveJudge or you need to know the cipher key, because we can also enter the cipher key in manually. The WaveJudge is not necessary. We also have a field on the GUI where if you do know the cipher key, you can enter that in manually instead of using the WaveJudge. So those are the two ways to do it. On a live network, we won't decode the messages from the folks that are out in the wild.
Right. So but you still can tell where are the PRACH messages or
Correct.
downlink share channel or control
That is
channel?
correct, because a lot of these messages on the WaveJudge GUI screen, all of the messages that are in the clear, we're going to show you, and the messages that are ciphered, we still show you the message on the window here. We actually show you that there's a message here, and I can even show you an example. I have an example of the Verizon network. I did some captures on Verizon a few months ago, and what it looks like. I'm going to open up this capture, and this is a capture in the wild in the Verizon network. And you're going to see that some of the messages are cited. So you can see if I stop, you can see they're probably somewhere here like this. So we still capture the PDCP, for example, but the data inside is scrambled. So just because the data is scrambled doesn't mean we don't show you the message. So yeah,
Right.
you are correct. We still capture the message. We still show it to you, but the data just happens to be scrambled when we click on it, right? If we click on it, the data is scrambled.
Right, right. So the other question I have with regards to the location of where you put the antennas in the live networks, obviously you need to be somewhere that you receive, high enough signal level from both the UEs and base station.
That is
So
correct.
how do you do that? Do you co-locate your antenna with the base station antenna, or any limitations in
Yeah,
that?
every operator does it different. I've done some testing in the field where we use the antenna coming off of the tower. Like we literally just tap off of the antenna coming from the base station.
Right.
We're using the same one. Sometimes I go to the middle of the cell and I'm using these antennas, and all of the downlink messages, I can see it, right? Because if I'm in the middle of the cell, the downlink is no problem. And I can see most of the uplinks. Sometimes you might have a UE at the cell edge, which we don't see. But the questions you're asking are very good, and you're on the right track. The location of the WaveJudge antenna is very important. If you're in a location where some of the cell edge traffic is not arriving with a high enough power level at the antenna, we won't decode it. That is correct.
Right. And you have different antennas for the uplink and downlink on this?
Yeah, on my example, yes, this one is a downlink antenna. It's a MIMO antenna, so there's two antennas in here, and I use this one for the uplink. But every network is different. This is for a sub-6. These antennas are sub-6. If you're doing a 5G millimeter wave, we use horn antennas.
Right. Okay. Yep. Thanks a lot.
But you're on the right track. The antenna, the discussion of antennas and which ones to use is almost a whole topic on itself.
Right. Right. Yeah.
To me, it's like black magic. I never understand the antennas sometimes. Thank you for the question.
Yeah. Thank you. Just I'm actually based in Ottawa myself. Is Sanjole originally based in Ottawa or another city?
Sanjole is originally based in Hawaii, Honolulu.
Right. Okay.
So we're not based in Ottawa, but I've been working for Sanjole for 12 years, and I go to Ottawa usually 1 week every quarter. Before COVID. So before COVID,
Right.
I'm spending a lot of time in Ottawa, but we also have a presence. We have a local Keysight team in Ottawa.
Right.
Quite a large one, actually. We have quite a large presence there. So if you're interested in a demonstration or learning more, ping us or send an email, or we'll get you in touch with. Maybe you already know the Keysight person that you're working with?
Yeah. Yeah. I know. Yeah. Thanks a lot. Yeah. It's useful. Yeah, because you were giving examples of RCMP and Canadian operators, I thought maybe
Yes.
it was Ottawa based.
I can give you. I have a lot of information, but I cannot give it to you on the seminar.
Yeah, good
Thank you.
interaction there. Thank you for that. Another question did come through on my chat, but before I go to it, I know we're coming to the top of the hour, so I don't want to lose anybody. I'll come back to that question in chat. But does anybody else have a live question they want to answer or ask? Just come off of mute and ask Kevin. Well, if so, just hit that microphone button and come off. But yeah, Kevin, someone asked, we may have talked about this a little bit, but someone asked if you can export captured data.
Yes, good question. I should have covered that. The answer is yes. All of the data you see on this window can be exported. We can export this protocol list. We do, and we can do that in a number of different ways, right? A number of different formats, text, CSV, however you want to do it. We can export all these charts and graphs. And what's really powerful is we can even export all of the captured data, the raw data, to various formats. So if you prefer to use Wireshark instead of WaveJudge, you can use the WaveJudge for capture. You can export to PCAP, and then you can open up that capture in Wireshark. There are, again, a whole number of ways we can get the data out of the WaveJudge software. A very good question. Many different ways to do it. Thank you.
Yeah, thank you for posting that question. Any others? Obviously, Kevin is passionate about this. He knows it extremely well. He doesn't just know the instrument or the tool or the solution very well. He clearly knows the industry extremely well. So we're fortunate to have acquired Kevin by way of Sanjole. We should have paid more probably for Sanjole had we met Kevin first.
Even with my gray hair.
Even with the gray. Okay. Any other questions before we conclude? Again, stay on for just. I think at the conclusion when we terminate, you'll get a pop-up window to evaluate, and again, you can ask questions or post comments there, open-ended. So, any other comments or questions? It looks like everyone's had a chance to ask, so we'll leave it at that.